Now I'm going to quickly start the main presentation, and I want to welcome Vladimir Vuskovic. He's the Director for Product Management in Google Cloud, and he's going to be giving a lot of today's presentation. I'm going to kick it off first with a quick review of AI for all of our high-performance computing and data analytics folks that haven't dug into AI at a level that will help you understand some of the technologies that Vlad is going to be discussing today. So first, an overview of AI in 8 to 10 minutes. This will be quick, it will hopefully be impactful, and it will solidify some things about large language models and foundational models and agents that I think will be very useful to you as we get into the heart of today's content. So you've probably all seen this Venn diagram before. Maybe you haven't seen the innermost circle for generative AI, but artificial intelligence is a large field with many methods. Machine learning methods are the dominant type right now used in enterprise and research. And the subset of those deep learning methods is, of course, really important for unstructured data. Within deep learning, we now have not just predictive AI, but also generative AI methods that have been popular ever since, about November 30th, 2022, and we'll talk about why. So first easy question, is linear regression machine learning? Let's give a thumbs up in the window if you agree with that statement or that question and you think the answer is yes. And so I'm glad to see this because we all did linear regression long ago in school. And we probably didn't call it machine learning when we did it. We called it statistics. And many of these data methods have overlapping boundaries. But it's really important to remember it because if you understand the principles of linear regression, you really understand the basic idea of deep learning for unstructured data. It's all about taking data that's known to be true, creating a model, and then applying that model to new input values to estimate new output values. You can see in this, the red line doesn't fall exactly on many of the points, but it's a very good representation of future values given an X, what the Y might be. So it's in widespread use, and of course, not everything falls on a straight line, so there's many methods of machine learning, and you've probably heard of some of these methods before. Regression is just one class of methods. There's clustering and support vector machines, random forests, and Bayesian classifiers, but the principle's the same. You train a model on known input and output data. Once you have that model, given new input data, it can predict or classify or judge new output data. Neural networks for deep learning are just a more advanced form of this model building. They're inspired by, they do not mimic, they're inspired by neurons in the brain, but they're really computational structures for taking an input layer of potential inputs. It could be pictures of cats, dogs, and sandwiches, and using a very intensive math, matrix algebra, to try to find patterns in that data so that they can classify on the other end of that neural network. These networks exist in layers, and you don't have to worry about this as a computational user. And in fact, you don't have to worry about it as a scientist in most cases. There are experts in designing these neural networks to optimize for transforming inputs to outputs. And you can use them, and they might even seem magical at times, but I assure you it's matrix algebra, not magic, behind the scenes. And in fact, you've got these feature detector layers where you're doing all these computations on inputs, and then you've got a classifier layer and the output layer. And it really is just these artificial neurons that have weights attached to them that are being adjusted in real time as you train the model to get most of the outputs correct on your training data set. And then you get these models, and believe it or not, it all comes back to linear regression. So as I said at the beginning, linear regression is a form of machine learning. It might be the hello world program of machine learning, but it is. And the principles of it apply even as you get into deep learning and all the things that we're going to talk about today. So that's why these things are so mathematically, computationally expensive. This is a vastly more intensive form of learning than the basic machine learning of linear regression. So in summary, machine learning is an approach to AI in which you're taking known input and output data and training a model so that you can calculate and predict outputs for new inputs. It's not a new idea, but it's more powerful in recent years due to big data, powerful processors, and optimized algorithms. And companies like Google and others have this vast scale of computational power and the ability to store vast amounts of data so that we can train these very large models that once trained can be used very nimbly and efficiently. And it's become really powerful when you have lots of data, especially deep learning when you have lots of unstructured data, text, images, sound, and video, these things that you're now familiar with manipulating using tools like Gemini and ChatGPT and Claude. These models have been trained on vast amounts of this unstructured data. Now, we need to be clear, these tools are not always perfect. If you're looking at the images on the left or the images on the right, you as a human are probably good at distinguishing fried chicken from curly-haired poodles and blueberry muffins from chihuahuas with dark eyes and a dark nose. Deep learning is actually better than humans at many of these things, but it's not perfect. It's still finding patterns in data, and the patterns in the data it's looking at are patterns in pixels, not in concepts that you and I are familiar with, like fried chicken and puppies and muffins and chihuahuas. So these things aren't perfect, but they're incredibly good. And the more data you have and the more you train them, the better they can get. And of course, we all know what happened a few years ago, and it seems like forever, but it was really less than 3 years ago when ChatGPT came on the scene and had a huge number of users within its first few months, because it seemed like magic. Now we had a tool that could seem intelligent and converse with you in natural language formats. It actually all started with work by Google about 8+ years ago in a paper called Attention is All You Need. This diagram on the right is a transformer network. It's a method within the deep learning field for, instead of classifying images as dogs or muffins or fried chicken, it's a method of given prompts, predicting what should come after these prompts and continuing to predict and generate new content, but all within the boundaries of the way the model had been trained. And so a transformer for text prediction will take a pre-trained transformer model, and you get the pre-trained transformer in ChatGPT, so that's where those letters come from, but you get a pre-trained transformer model, and it predicts the next tokens given some tokens that result from the prompt. And then it continues to predict new tokens and continues to generate new text. And the better your prompt and the better the model, the better the outcomes are going to be. And if you save lots of this in a very large context window, it gets even better and it improves its accuracy more and more. So this is a very powerful capability. And that was my very quick overview on AI to set the stage for what's going to come next. Now, Vlad is going to talk about some of our most powerful tools. I'm just going to give you a few quick notes to set of Google specific tools to set the stage for that. First, I'm going to define a few terms that you've heard of before. Foundational models are these large general purpose generative AI models. A frontier model is a foundational model, but it represents the most advanced capabilities. For example, when all the foundational models started adding in multi-step reasoning capabilities, those are frontier models. But you can think of this as largely the same. They're very, very large, well-trained models. And a large language model is one of these models that is trained on a massive data set of text. So specifically focused on text and language, and that may include coding as well. Vlad's going to talk a little bit more about mixed modalities coming up. But these are three terms you've heard of, and Gemini 2.5 Pro is really all of the above. The advanced thinking capability is what makes it a frontier model. It also has a massive context window, deep multimodal understanding, and the ability to power advanced agents that Vlad is about to talk to. There's a couple of other tools you might have heard of. Gemini Canvas is a wonderful interface within Gemini that you can use for creative writing, for coding, for lots of other things. And of course, the one that even Jensen from NVIDIA has talked about using all the time is NotebookLM, because that allows you to upload your own information, including scientific and technical content, your own papers, your own research, and that will further help guide the kinds of generative AI content that these things produce. NotebookLM is, it probably got most famous for its audio generation capability and the ability to make simulated podcasts out of the content that it generates. But its real power for you all as scientific and technical computing users is being able to upload lots of content that you want to have priority in the generation of text that it's creating. And there's a few other tools that I'll just mention real quickly, and we're going to talk about these in August sessions. And they are Gemini Code Assist, a great coding assistant, Google AI Studio, a great place to go and develop AI applications, and the Vertex AI platform, which includes Model Garden that has many models in it, our own Gemini models and many others, and an agent builder so that you can build your own agents that run in that platform. And with that, I'm very happy now to introduce, again, Vladimir Vuskovic, the Director of Product Management at Google Cloud. And he is going to take over now and talk to you about Agentspace and some really powerful agents in that. So Vlad, thanks for joining us today, and take it away.
Thank you so much, Jay. Let me now try to take over the presentation so I can present. Let's see if this works. Oops, do you all see this? Oops, do you all see these slides now?
Yes, we do.
Excellent. Then I can take it over from here. So Google Agentspace, so this is like a new product that Cloud is launching to the market. I'm going to describe a bit, what it is and why we are working on it, what it can do, and some of the agents that are part of it, as Jay was mentioning. So everything started by recognizing that today there are really three big trends, right, in the technology. I mean, there are many, but I think, I really like to think that these three are, kind of the most salient ones today that I see. So the first one really is, that we are in the presence of models that can not only answer questions across multiple modalities, meaning, voice and images and text, both as input and as output. Like we can input to these models an image and ask what is inside, or input a video and ask it to analyze it. And we can also create, very, very realistic images and videos, or get answers. That's like one thing. But even more importantly, these models, like as the Gemini 2.5 Pro, for example, is not only able to understand these modalities, is actually able to think through the problems in this multimodal space. And I think this ability to think through problems and kind of creatively come up with solutions is really the key capability that is driving a lot of other things that follow, including the other two trends that I'll talk about now, right? The second trend that we are seeing, and it's especially important for Google, is the knowledge frontier. So with generative AI, really the way that we discover and interact with information is changing. So on Google, we launched AI overviews, AI mode, to really enable users to experience and find information in new ways. And then the third, this is like maybe the latest kind of trend that is bubbling up is, the AI agents or agentic workflows. This is really something that is omnipresent now, like in all of the press and like all of the kind of research literature that we are seeing, and also in the applications in the companies and academia that we are working with. Like this kind of omnipresence of agents is really, I think, mostly driven by the fact that the models of today are really getting really smart and really capable of two things: of solving problems and then following instructions that we give them. So given these three kind of big trends in mind, we really wanted to create something that kind of enables users to use this in a very effective way. So again, I go over the three modalities. So we talked about the multimodality. I described a bit how the models are able to understand them at the same time. This comes from the fact these models are from the ground up kind of trained on these modalities, so they natively support them, really understand these modalities together. The second trend that we talked about is the new ways to search. Again, here are like two examples. One is the AI mode that Google just launched to to all of the users on Google.com. There are AI overviews to get the answers, AI mode to interact more efficiently. So it's the most powerful way to search. And then like interacting with information, Gemini really enables you to kind of together with the multimodality of models to really kind of do new type of things like circle to search, try on virtually, and many other ways to to search for information in a multimodal way. And then, as I said, kind of the evolution of agents. This is something that is really driving the momentum right now. So if you think about agents, so I will super quickly kind of go over the evolution of agents. So the first kind of agentic system, in a way, if you think about it, is just a large language model like that Jay introduced, plus a prompt, and then we get an answer out of that. So that's like the most basic agent. It's not really an agent, but we can think about it as kind of the precursors of agents, right? The second type of agents are kind of a bit more powerful because in addition to getting like a prompt and with kind of the question that the model should answer, it is also able to do retrieval augmented generation. So basically, like in this configuration, the model is able to search some sources and then include the information from these sources. These sources might be maybe some private data that belongs only to you that nobody else can access, or it can be maybe like the Google search data. So with this ability, the models kind of suddenly are able to answer questions on data that they didn't have access to at the moment of training. And that can be because they are data that belong only to you, or because it's fresh data that's real time. So now you can ask models to answer, or agents to answer questions about live sports results or weather or things like that. The next kind of step in the evolution was, okay, in addition to being able to, kind of retrieve information necessary to answer questions, right? The model kind of in this step were enabled to also use other type of tools. So in addition to using, the search as a tool to kind of retrieve information, it's also able to use other tools. One particularly powerful tool is code as a tool. So basically, the models are able to, like solve particular type of problems is to write the code on the fly and then run the code in some sandbox, and then basically use the output of that tool, to answer the question, right? Or other tools might be, I don't know, like very simple kind of idea would be a calculator, for example. So those are the type of things where or booking a hotel or like any type of kind of API call, essentially. So by using kind of these three things together, the agents kind of starting, or the models starting getting kind of really more powerful. But then kind of the first like real agentic systems are when you start doing this in a loop, right? So you're not only kind of directly given an answer based on, maybe retrieve information based on maybe calling some tools, but actually you're iterating, through this to achieve some goal that the user gives you. And you're iteratively kind of using tools, retrieving information, thinking through the results of calling these tools, using the tools or the information and so on. And then the next level, which is where we are today, is multi-agentic systems, right? Where basically you have, and then there can be a multiple configuration of the systems, but you have multiple agents that are talking to each other, trying to solve, like a particular problem. And maybe, there are like multiple configurations of these agents where, the router agents, maybe there is like a master agent that kind of governs the overall task, and then it delegates the calls to like, subs agents that are specialized to solve a particular simpler problem, right? That then yield back when they're done, to more complicated, kind of type of configurations. But essentially still, those are kind of there's like a lot of happening in these multi-agentic systems and the research in the various configurations. So here is where Agentspace really comes. Like Agentspace is, the ability to kind of connect, the data sources that you have that are accessible only to you. I'll talk about it in the next slide a bit more in detail. And then being able to really kind of search on top of this data, being able to put the generative AI, the power of large language model on top of this data, so they are able to answer questions that are, on data that is only available to you or to your company or to your entity. And then also, kind of the ability to build agents and AI automation on top of, on this data. So really, the purpose of Google Agentspace is to deliver these three kind of current technological trends to every institution and every company, so that they can use it on the data and the automation that they want to do. So if you look at this from another angle, the same problem, right? But this is something that we know that every company, even in Google, like we kind of work across many different applications. So our work is not, or very rarely, occurs in one single place, one single application. So maybe, like the typical journey in the work that we do is maybe we receive an email and there is some task to be done there. And then maybe, in order to answer to this email, we go and we, give a look at some tickets that have been opened on some issues, right? And then that kind of triggers us to go and, look at some documents. And maybe from there, we need to go and, run some evaluations or, some simulations or whatever else that's yet in another system, and so on, until we go kind of get back to the data to send back to the user. So this kind of fragmentation of our work and the fragmentation of where the data resides, right, has made it like really difficult for generative AI, with all of its power, to actually be useful inside enterprises belong just kind of siloed tasks, right? Or kind of manual copy pasting stuff around. So Agentspace really kind of tries to solve this problem. And kind of basically it allows customers to connect all of these systems together into one kind of system, right? So basically this is like a layer that understands the data from these various, hundreds of systems, and preserves the access control so that, you still have only access to the information that you have access in a single of these silos, right? And then basically on top of that, now you can, once you have the data in one single place, now you can, find the information from one single search bar in a way, right? Across all of the systems. You can run, Gemini or other large language models on top of all of these systems, and you can kind of start creating agents on top of these systems, all with, kind of the compliance and the privacy that you need to do. If I, so one of the, sorry, just a second. I'll be there in a second. Okay. One other like really important thing, right, is, like there is this, as we talked about, these agents that come in multiple configurations. They bring a lot of power with them, but they also are, not, it's not like immediately clear how you can leverage them, how you can develop them, right? Google has been working, on several ways to build agents. So we released at Google Next in April, we released ADK, so that's Agent Development Kit, to allow developers to build agents in code in Python and Java and other languages. And also released the agent-to-agent protocol that basically builds on top of the MCP protocol for Anthropic that kind of standardize the ways that we can use tools. Agents to agents kind of standardize the way that these kind of multi-agentic systems, are implemented, and how agents talk to each other in order to kind of achieve some goal and some task. So on top of these things, we also, are building a few no-code interfaces to build agents so that everybody can automate, the tasks that they have in mind, by simply, using like human language as the way to, to kind of program these agents. Or there is also like a visual editor that kind of gives you some more control over some flows that you want to automate better. On top of these, the Google is also bringing, to as part of Agentspace, like a few dedicated high-value agents, like first-party agents that Jay alluded to, and that I'm going to like quickly talk about. So one of them is deep research. This is something that you might have seen, in other kind of across Gen AI in general. This is a super powerful tool. I use it literally like several times every day. It saves hours of work. Basically, the idea here is that I can give like a task to the model, and then tell it to not just give me an answer right away, but to do like a thorough research, and then come back to me, with like a more thorough analysis, right? And usually, what happens, these agents will go in the background and then kind of research hundreds of sources that can be external websites. It can be internal websites that you give it access to, or internal set of data like documents that you give it access to, and basically kind of compile like a very comprehensive research out of that, right? This is something that's extremely useful. If you haven't used it, I really like it's available in the Gemini application. In Agentspace, it's available in addition to kind of using the web sources. You can connect it to your data sources internally, and it can do the same type of deep research on top of your data. So now this is like one extremely useful agent, that is available, and that today is kind of getting more and more traction. It literally saves hours of work every time. Another thing that we can do is kind of like take this idea to the next level. And I wanted to describe like kind of what is the core idea behind that. And then kind of we'll introduce like two surfaces where we are making this available. So the idea here is to, instead of like running, like one deep research agent to find a solution to a problem that I'm giving, or to do a research to a problem that I'm giving it, we can actually do even more. We can do, in essence, kind of start maybe like hundreds of agents that each one is tasked with kind of finding a solution to the problem, right? Or maybe generating ideas to a particular problem, or hypotheses of what might be happening in a particular situation, right? So instead of like running one agent that does deep research, we can run hundreds of agents in parallel. Then what we can do, we can now go and and we can review each one of these solutions or ideas that come out of that, right? After we review them, we can annotate them. We give them some some scores, and then we can actually do like even more. We can now let them compete against each other in a chess-like tournament. So basically, there are algorithms where we can kind of choose the pairs, and we kind of let the ideas compete against each other, and then the best ideas will start bubbling up. Basically, exactly like in a chess tournament, the best ideas will start getting like the kind of the highest Elo scores, right? As we're getting Elo scores, now basically that enables us to bubble up the best ideas on top. And then what we can do, we can now, think about, these are the best ideas. Some of them we can take as they are. Some of them maybe we can combine. We can kind of take the parts of one idea with parts of another idea and generate like a hybrid ideas out of that, right? And then what we can do now, we can take these ideas and kind of get them back into the system and kind of learn from, do like a meta loop on top of that, learn and figure out why are the ideas that are winning, right? By looking in, what is happening, and then kind of improve the way that we are rating the ideas, improve the way that we are generating new ideas, and run this loop in continuation. So this is basically what there are two implementations of that. One is the idea generation agent, which will be available as part of Agentspace. So here, let me switch to another tab to present. So I will share this. This is like a real implementation here. I just started this maybe an hour ago. So this is, I asked Jay, like, what would be an interesting problem for this community, right? And then Jay told me, he gave me in 5 minutes, 20 ideas. I selected one, right, which is, give me some ideas how I can design the fault-tolerant systems for parallel applications of Google Cloud. Jay, feel free to jump in at any moment. But basically, here is like a set of ideas that the system came up with. All of these are basically deep research kind of, solutions to this problem. We can go and kind of now look into this. Like this bubbled up at the top. It kind of won the tournament, right? So it's, it has been selected as the best idea with the Elo score of, 1,660. We can now look into it. So, it can This is kind of the idea overview. So this architecture provides high fault tolerance, application with the cloud through a hybrid approach. It uses replication, checkpointing, task redundancy, and managed services like GCS, GK, and cloud monitoring. So the core innovation and so on and so on. So basically here you can see the description of this idea. How does it work, right? Like all of the points. You can see some. What does it scale? You can see a diagram for it. You can see the review summary. This is like the summary of kind of the reviewers. What were positive reviews, what were kind of feedback and concerns about this idea. You can see the tournament performance. It kind of, it played 12 matches. It won 12. It kind of never lost, right? It has like a very thorough review. These are the references. These are all kind of public references because I run it just on a kind of public data sources. But this is like just one of the many ideas here, and it kind of like this is another one. I can kind of go over it and look into the idea overview. I can look at the description, right? For example, this one kind of played more matches, so played like 51 matches. It won 41. It lost 9. Here is like some kind of details of what it won, what it lost, and so on. But as you can see, this system is kind of really, really powerful to let you generate new ideas. This is why it's called idea generation agent, but also to kind of start creating solutions to particular problems. Now I'll go back to the presentation of before. And let me just present this again. So now if you take this to the even next level, right, then basically you get to a system that is implemented kind of with a very similar kind of core ideas at the background, right? That is called Co-Scientist, that we also published the paper and announced like I think it was beginning of the first quarter of the year. Here is basically a very similar type of configuration, but a bit more in depth, right? So Co-Scientist is able to, while idea generation agent, runs and kind of finishes maybe in, 1 hour of time and generates somewhat like maybe 50 or whatever 100 ideas. The Co-Scientist runs much more deeply, like you can configure it, and like we're using it to, actually go and solve really difficult problems. So we are working with, some of the top universities in the world, to solve really novel and really complicated problems. For example, just one last example, we went through the ETH Zurich, like a few weeks ago, and we are looking at some quantum physics problems and kind of looking in, kind of creating new hypotheses about why some natural phenomena are occurring that are not, understood yet, right? So the Co-Scientist is like basically, but using this type of ideas with, some more thorough reflection and kind of generation of hypotheses and, testing of hypotheses and like some more thorough meta loop to kind of learn from the various runs, is able to really kind of come up with breakthrough solutions to, to problems that we were not able to solve so far. So with this, I hand it over back to Jay to finish the presentation.
Thank you so much, Vlad. I'm going to share one more slide on our AI applications at Google. So Vlad talked to you about idea generation agent, deep research agent, and a new tool for which we published a paper about. It's not in production yet, called AI Co-Scientist. Before that, I shared with you some of the consumer and enterprise grade tools that Google already has out there that you can use. I should have added one thing about the enterprise versions of those. You can upload your own data into those, such as NotebookLM, and that data is protected. Only you get access to that. It's not absorbed in any future training models or things. So a lot of people are finding these tools like the enterprise version of NotebookLM very powerful, but now you've seen a couple of truly powerful tools that should help you be productive across your computational science efforts. We also have some domain science applications for scientific discovery, and we've published about these, and some of these, the first one in particular is available right now, AlphaFold 3. In fact, AlphaFold technology was used in last year's Nobel Prize in Chemistry, so it has proven itself at the highest level of science. WeatherNext is available for very rapid and accurate weather forecasts. Its main benefit right now is actually its speed. It is much faster at generating forecasts in the traditional numerical weather prediction simulation models, while it's also achieved some accuracy successes as well, including predicting the path of Hurricane Beryl a year or so ago. So we have some new things coming up in WeatherNext that we'll be talking about in the near future. We've also published a blog post on the Google blog about Alpha Genome. I won't say too much about it here. It complements AlphaFold 3. It's more about science that you can do with the whole genome as opposed to the proteins and biomolecules that are created by the coding regions of the genome. But we'll talk about that more in a future session as well. AlphaFold 3, however, is the topic of the next online session. I hope you will tune in for that, because we'll talk about AI methods for doing science in a way that was normally done with physics-based approaches. We also did that with WeatherNext a couple of months ago. We'll do that with AlphaFold 3 next week. We'll move to Q&A now. So I'm going to look at the questions here. And Vlad, you're going to want to come back online because these questions are going to be largely for you, I believe. Let's see. Bill Turner asked, does this application of HPC have file size limitations? And I believe Bill submitted that question while you were talking about either deep research or idea generation. Bill, I will say it's not actually an HPC application, although the training of these models is absolutely done in an HPC-like way on a very large, tightly connected cluster. But the application itself that he was using there has already been trained, and you're asking if it has file size limitations, Vlad.
No, the idea here is that you can connect, your data sources to Agentspace, right? And then, like we are using kind of RAG type systems, right? That would search and get, the appropriate amount of information. So the size is like not the limiting factor, because we are not like putting everything in the context of the model, but just like picking like the most important pieces, right?
All right. There is, I believe, though, Vlad, still an upload on the amount of information that you can absorb. At least there is in NotebookLM. It's a huge number, but isn't there one for co-scientists still some upper limit on how much content you can upload?
No, I mean, as long as you use, there's like various implementations. As long as you use kind of the retrieval augmented generation system, right? Then basically we have search where we, basically we divide information in pieces and then load the most relevant pieces out of like a big repository. So there's like a search moment where, out of like a huge kind of repository that's potentially infinite, right? You can get, you can basically get the most relevant parts. And then you will use that parts to kind of put into the context, right? So there is no particular limit, in the final implementation of this.
All right. I'm going to take another question from Bill because I think it's a fun one. Does it incorporate a set of guardrails from region to region to address ethics? And there, I assume he was probably referring more to the idea generation based on the timestamp here, to make sure the ideas that are generated are appropriate from an ethical context region to region.
So, I mean, Google has AI principles, right, that are like kind of like deeply embedded in Gemini and Gemini training and, and Gemini serving, right? So there is like several parts of the stack that look at, into this type of kind of responsible AI, kind of perspective. So from that point, yeah, like, like the nature of Gemini should ensure that the ideas that are generated with it are kind of, ethical.
All right. Joshua Williams has a question. Welcome back, Joshua. I love seeing you being a regular on these sessions. How does Google approach explainability in AI-generated hypotheses or experimental designs, especially in high-stakes research? Do tools like AI co-scientists provide confidence scores or references alongside their outputs?
Oh, that's a really great question. This is like really important as well. But the scientists, they don't want to waste time to kind of have to double check, like some of the facts. So co-scientist has several steps. One of the steps is to generate, as part of the idea. So I didn't show that. In the idea generation, it's a bit more lightweight. In the co-scientist, it will generate kind of set of facts that it uses. and those are checked multiple times, so to basically give you some more confidence. And there is also some confidence scores, right, to give you more confidence into like how truthful they are. By nature of it, the idea is to find new ideas, right? So new ideas cannot be necessarily 100% validated, but at least the facts that it kind of derives from existing knowledge to then use to kind of generate new ideas, those are checked. Yes.
Yeah, and I'll add a little bit to this. We've done some demos of idea generation in front of computational scientists, and I have seen on multiple occasions where scientists will look at the outputs that were generated. And you saw, Vlad showed you a ranking of these, and that ranking is its best ranking of those. It doesn't mean you'll always pick the top ranked idea to pursue. Your interests may be different, your expertise may be different, the resources available to you to execute the research plan for that idea may be different. But we've had researchers look at the list of top ideas generated and be very impressed and say, oh, I've actually thought about pursuing that path, but haven't done it yet. And there's a criterion in there that you can set for idea generation to guarantee novelty. Of course, novelty can only be guaranteed that it hasn't been published somewhere that idea generation could go and access the information about that idea. So if it's just in your head and you've never put it down on paper, it might mimic an idea that you've come up with. And we've seen that happen where people have had ideas not published yet, not written down anywhere, not accessible to the model training, but the model has come up with ideas that they have been thinking about. So it's just anecdotal, but we've had sort of some validation from scientists that a lot of these ideas look very promising, at least at first glance, to people that are experts in the field. Let's see, next question. I got a question from Deepak Suresh. Thanks for the very nice presentation today. How can organizations predict/calculate the cloud billing costs while having no idea about the resource usage by agents in the background? Can I have an AI agent for this as well? Deepak, I don't think you're going to need an agent for that. I think Vlad's going to have a different answer for you. Vlad?
Yeah, it's kind of, it depends on which type of agents we are talking about here. So deep research, for example, the one that I showed, right, that's kind of included in the subscription price for Agentspace, right? Yeah. Or for that matter, like the deep research in your Gemini consumer application as well. For co-scientists, like we still did not disclose like the how like what is the monetization model for this. So this will come soon, like so. But yeah, you shouldn't be like whatever we do, we will you shouldn't be kind of calculating like token by token.
Yeah. So as he said, subscription is one model, and for AI co-scientists, the exact model has not been determined yet. Vlad, can you say anything about projected timescales for being able to know more about co-scientist availability and pricing? Is that something we can share or not?
Yes, like we are now basically actively working on making kind of cloud compliant version of co-scientist, right? So that we can, that you can actually run it on your data. Right, with all of the cloud compliance guaranteed. We are thinking of timeframes that are over, the next few months, right? So it's like fairly, close point in time, yes, as a private preview, right? And then Jay will follow up later.
Yeah, and we'll certainly come back and revisit that after it is more broadly available to people. I have a question from Surya Kalaga. Does Google Cloud have any AI models to assist/optimize the performance of computer-aided engineering, for example, CAE, FEA, CFD, simulation applications? Vlad, do you want to take this, or do you want me to, or how do you want to do this one?
Feel free, Jay. That's like right in your expertise.
So one of the applications I'm most excited about that's come out of the Google DeepMind team is called Alpha Evolve, and there's a blog post on it. It is not available. I cannot say too much about it yet, but you can read the blog post about it and see how Google has actually used this application in everything from design improvements in TPUs, our own silicon, to design improvements in how we schedule jobs across our underlying, it's called Borg, our underlying Borg infrastructure. So Alpha Evolve, I think, is going to be our most in-demand tool in many ways in the high-performance computing community, because it finds new algorithms, new, more efficient ways to do things. And it uses this evolutionary evaluation-based approach to keep improving the algorithm until it finds new ways to do things. That, for example, it found a new algorithm for a 4x4 matrix multiply that the previous algorithm had stood for 70 plus years. So it's really a powerful thing. And this community of practice is going to be very impressed by it. We don't have a talk scheduled on it yet because it is still not a GA product, and I can't even reveal timelines, much less pricing and availability, much less the solution design for at this point. But I know Vlad and his team and others are actively working on this to try to figure out what is the right solution to deliver on this in the future. And that's probably all I can say about that. Vlad, is there anything else we can say to a public audience?
I think this is exactly what we can say. Yes. Thank you, Jay.
Great. Thank you.